Okay, so we are in the ninth part of single field analysis. Today we are going to discuss about global indices. Okay, let's move. The very first thing that we want to understand about global indices is it provides a grand summary that captures something about the single field paper or which means the grand summary means it provides the field in a single number, okay, of a single field analysis definitely. So grand summary it gives global. That's why global indices all printed sensitivity measures in decibel along with p-value, okay. And obviously in pattern standard deviation there is no p-value. So there it consists what? It consists mean deviation and pattern standard deviation. The main player, another player is short-term fluctuation and corrected pattern standard deviation. We will definitely talk about this very briefly, but these are two giant player. Okay, just to understand this concept. So all the concept of global indices, a single digit or whatever number, comes from the concept of Hill fusion. That is this Hill fusion, isn't it? Hill fusion means this is blind spot, isn't it? This is blind spot, and this is center of fixation 0 degree, which is fovea macula. And here the field of vision is maximum at peak, okay, is corresponding to 34 35 and decibel vision. And as you move towards periphery, field of vision goes down. So this is blind spot, and again it goes down. Temporally there are a lot of space, isn't it? And always blind spot lies in temporal in front to fixation. So there is a two concept of field of vision. There is two things that we understand from. One is a height of field of vision, that's 34, and whatever, what if its height decrease. Another is contour. You know that contour is this line, isn't it? What if this contour becomes more irregular or becomes single area is defective? Like for example, this kind of contour goes like this area is defective. So one thing is the height of the hill of vision decreases, that means mean deviation. Another thing is the contour becomes more irregular, that's its pattern standard deviation. So that's two things we are going to discuss solely in mean deviation and pattern standard deviation. Okay, to express the height of field of vision, the contour of the field of vision global indices are developed. The mean deviation index expresses change in the height of field of vision. That's what I have discussed. Okay, mean deviation means height of field of vision decreases. Mean deviation means, and pattern standard deviation expresses change in the smoothness of contour. I have already told you one thing is height, another thing is contour. Contour of a hill of vision. If pattern of contour becomes more and more irregular, pattern standard deviation becomes high. Okay, that's simple. As it becomes more and more smoother, pattern standard deviation becomes zero. I'll definitely next video, next slide. Sorry. So mean deviation. Mean deviation indices signifies the average overall sensitivity loss. Just remember, average overall sensitivity. The average of all total uh, total deviation numeric plot except 2 points. That 2 points fall in the blind spot. Basically means 24 dash 2 means 52 points. Okay. So the difference in mean deviation between two eyes should be taken into serious clue or confirmed diagnosis of glaucoma. In case of glaucoma, difference of the two eye, difference in mean deviation. One deviation difference in mean means, see, 52 points, isn't it? There are 52 points, 54, 20 dash to 54 points, in which 2 points are not considered. The 54 points. So one deviation, mean deviation difference mean every point has one deviation difference. That means 52 deviation difference between two eyes, isn't it? That's quite fascinating thing to understand. And it is the most important index to assess. It is the most important index to assess the field of vision defect progression. Whenever we are talking about progression, mean deviation is zero, not pattern standard deviation. Okay, so we in that particular case we expect mean deviation change 0.08 decibel per year. Mean deviation can be increased due to the reason of cause generalized field defect. That's what very important. Generalized field defect can cause significant mean deviation decrease. Example: refractive error without correction, cataract, vitreous hemorrhage, optic nerve defect, uh, whatever others. Okay, so the negative value represents depression of the field of defect, and positive value represents elevation of the height of the field, the basically hill of the field. But positive, we don't think about it. Okay, normally from +2 to -2, we think it's completely okay. Mild defect means -0 to -6. Moderate defect means -6 to 12. Severe defect means greater than 12. So basically, loss of sensitivity distributed equally to all points means mean deviation. Mean deviation means all points decreases of by how much or increases by how much. That's it. It's very important. Just remember, if depression of the field is not significant, mean deviation will simply be number without p-value. If there is mean deviation, for example, 2 decibel, and there is no p-value, then just leave it. Don't think about it. It's normal. Just leave there and there. Okay. The role of mean deviation in the index of diagnosis of early glaucoma. Just I'm going to grab it speedily. Okay. If we suspect glaucoma on the basis of asymmetrical intraocular pressure and Dixon copying, the difference of mean deviation between both eyes should be taken as serious clue, as I have already discussed. There are three things that you have to understand. 2 decibel difference in the mean deviation between the two eyes, you have to take it seriously. The average of 1.5 difference must be maintained between the two eyes on a consecutive test. If you test for the follow-up, then you must know 1.5 decibel average is good to go. The average difference between 1 decibel must be maintained between two eyes for 4 consecutive tests. If you come to the follow-up and 4 consecutive tests, you must understand at least in first and fourth, there is 1 decibel difference between two eyes must be maintained. If that gap broadens, then it will be problematic. First follow up 1 decibel, second follow up 2 decibel, third is follow up 3 decibel, then you must suspect there is going something. Okay, the role of mean deviation index in follow up of the test. Follow up what you are saying. So most important parameter is mean deviation. Sometimes people feel that pattern standard deviation. No, that's mean deviation. Okay, and another thing that we have discussed already, every year 0.08 decibel decreases in mean deviation. That's normal, but just in follow-up, just remember, if it is increases mean deviation, the rate of decreasing mean deviation increases by 0.08 per year, more than 0.08, and then you should consider abnormal and you should think about it. Okay, there are very much thing to do with the mean deviation. So this is the concept. If there is a local defect, then general, then mean deviation definitely field of vision decreases from this point to this point, isn't it? If there is a uniform generalized defect, then field of vision decreases by significant amount, isn't it? That's the simple concept we have to understand from this picture. This picture again taken from GRAT. Now come to pattern standard deviation. What is pattern standard deviation and how do you need to think about pattern standard deviation? See, the pattern standard deviation means express a dissimilarity in deviation between total deviation numeric plot where it is smooth or not. Means one number from total standard deviation is 27, another number closest to it becomes 17. And this is the rough, isn't it? It's from 27 it went directly below, and from 17 it will again to go to 29, and from 29 it will go to, for example, 20. It means a roller coaster, isn't it? It's not smooth, and that roughness we have to understand, given by pattern standardization. The roughness of the hill of vision can be either due to the loss of sensitivity or measured sensitivity being better than the normal vision. Pattern standardization does not carry plus or minus sign. It's very important. Doesn't carry plus or minus, but it carries p-value. Okay, it is just a simple number because it's about roughness. It's not about height. Okay, its roughness is slope is not significant. Pattern, if roughness of the slope is not significant, pattern standard deviation is simply without a p-value. It will always be there. If MD or PSD comes without p-value, just don't think about it. You move ahead. It means it's normal. Okay. If the deviation of slope is significant, it will be represented by p-value. It will be represented by p-value. Okay. So the pattern standard deviation with significant p-value indicate the number of total deviation numeric plot are not similar to each other. Means total deviation numeric plot is like roller coaster. I have told about that. So pattern standard deviation is higher in localized or irregular. That's the correct thing that you have to understand. Higher in localized and irregular, but lower in uniform generalized field defect. At the same time, if uniform generalized field defect is there, then MD is higher, mean definition, isn't it? So pattern standard deviation pick up the localized scotoma. That's very important. That's why it's very important in early diagnosis of glaucoma. It's very important, pattern standard deviation. So useful in early glaucoma. But once the glaucoma is diagnosed, pattern standard deviation is very minimal role in the management of glaucoma. It's very important. Pattern standard deviation is very important whenever you are diagnosing glaucoma. Okay, pattern standard deviation less than 6 is as considered as normal. Hmm? See in this picture. Yeah, see what I am told in 0 and -7. Isn't it huge gap? Yes, it's a huge gap, isn't it? So that's like 34 and 5, isn't it? Very huge gap. So that roller coaster creates this gap here, like irregular. In this case, the contour is again irregular. So a rough counter pattern stand deviation high. Rough counter pattern but here see contour is so smooth. So pattern stand deviation is low, which means the distance between -8 -9 very smooth, isn't it? Not a roller coaster. And that matters. Okay, but here you can see second 14 and 7 almost double. That's why the heel is irregular. The irregularities or focal zone defect is pattern stand deviation goes high, but there is a smooth contour, which means low pattern stand deviation. Okay, now just read it and just try to understand a few things. Okay, so pattern standard deviation index developed to pick up the dissimilar deviation values on the total deviation numeric plot. For the practical purposes, it is the index to pick up for localized scotoma and scotomas which early sign of the glaucoma. So that's central important to pick up the localized scotoma, and localized scotomas are the early sign of glaucoma. That's the diagnosis of glaucoma. Pattern standard deviation is important. So pattern standard deviation helps to diagnose glaucoma at an early stage. And please remember that once the glaucoma is diagnosed, pattern standard deviation is very minimum role in the management of glaucoma. Then mean deviation is more important. Pattern standard deviation with a significant p-value indicates the presence of localized defect and can be either pure localized defect or localized defect in generalized depression with irregular generalized depression. So basically means pattern standard deviation do not have plus or minus. Higher the value of pattern standard deviation means higher the irregularity. That's simple. Role of the pattern standard deviation in follow-ups. Increase MD index and change in the pattern standard deviation indicates the progression of the field of defect. But at the same time, the confined local area and localized generalized depression. MD, and if there is change increase in MD and no change in pattern standard deviation indicates what? Indicates uniform generalized defect, not focal generalized defect. Okay, short-term fluctuation is very simple. Short-term fluctuation is an intra-test variation. Basically, it's a series of tests. First series of tests is done and calculated, and second series of tests is done and calculated for threshold. The difference between the calculated and express root mean square of the standard deviation is estimated in this particular location. Short-term fluctuation less than 3 decibel, between 1 to 2.5 decibel, value higher than that shows the index is unreliability or pathologic. Basically, up to till 1.1 to 1.25 decibel, it's tolerable, but above that, it's not. And one thing that you very important, short-term fluctuation and corrected pattern standard deviation is not calculated in CETA strategy, but it's calculated in full threshold and fast pack strategy. Okay, that's important. So basically, yeah, we have same thing. In theta, there is no nothing. Is there anything? No, single digit. Here is the corrected pattern. 23 one time and 17 in bracket. Can you see this? These are the short-term fluctuations. Okay. So corrected pattern standard deviation means pattern standard deviation corrected for short-term fluctuation. It's okay. Pattern standard deviation corrected for short-term fluctuation. Since the moment-to-moment variable in short-term fluctuation may cause the a patient to fail the response sensitive to particular reason, generally localized depression adversely affect the pattern standard deviation. Thus, corrected pattern standard deviation adjusts the short-term fluctuation and separate real deviation from the deviation due to variability. Normally, correct pattern standard deviation should be less than 6 because pattern standard deviation should be less than 6. Corrected pattern standard deviation should be less than 4. Okay, so higher the short-term fluctuation sometimes indicates pathology and sometimes indicates unreliability. It's very important. That's why I am not giving so much time to pattern standard corrected pattern standard deviation. Okay, sometimes unreliability. Just understand this thing. It is also used to correct the pattern standard deviation produced. So basically, it's not that important, but just remember sometimes if corrected pattern standard deviation is high, short-term fluctuation is high. It's not just about the pathology; it's about unreliability too. Okay. So that's it, I think. Very important: mean deviation, height of field of vision, pattern standard deviation, irregularity in the contour of field of vision, short-term fluctuation, and corrected pattern standard deviation. Pattern standard deviation corrected for short-term fluctuation is corrected pattern standard deviation. It must be less than 6, it must be less than 4. There are rough guides. Just don't think about these two things because these two are major game changer. Okay. And again, GR Reddy, the great book. Just grab this book, and this is also a good book. Okay, so I think that's it for it today. Bis dann, tschüss.